Imagine that you're asked to calculate the height of a building. Yes, you listen to me right. Imagine that you're asked to calculate the height of a building. And the only materials that you have are a metric tape and a protactor. Hi, I'm Agufim, and today you will learn about trigonometric ratios. Okay, so this is a problem that we may say, okay, but how could I find out the height of this building if I just have a metric tape and a protactor? I need to know this vertical value, and maybe I can have this horizontal value. I'm going to call the height of the building A, and I'm going to call this distance B. So you will say, okay, but how could I get the result if I measure this angle? So the first idea that you can do is that after you have the distance B, you can have this angle by using your protactor. So you can just watch up to the building, take your protactor, and measure the angle that you're doing in order to watch the building. Okay? So this is what in measuring you call angle of elevation. And we have measured this angle. So something that is pretty interesting about this angle is that we can have infinitely similar triangles with this angle theta here. So for example, I'm going to write here this blue. Okay, I'm going to do it with ruler. So let's say that I'm going to do with blue this angle, and if this is 90 degrees, so we have here B prime and A prime. Okay, and we can name the hypotenuse. Red hypotenuse will be C, and blue hypotenuse will be C prime. Okay, and there's something that you may find out pretty cool about similar triangles, and it's that the sides should be proportional. So if I take A over B, I'm going to use black. If I take A over B, this should be equal to A prime to B prime. Or if I take A over C, it should be equal to A prime over C prime. And if I take B over C, it should be equal to B prime over C prime, and any other combination could be allowed here. But here is the cool part. These ratios depend on this angle. As you could see, if I increase the angle theta, A divided B, or the ratio A to B, should increase or decrease according to how did I increase theta, in this case increase. So these ratios depend on the sides, on the angle theta. Okay? So in this way we can say, like, okay, if those ratios are constant between to any right triangle, but they depend on the angle theta, maybe we can define a new way to express these ratios using the angle theta. So I will know that anytime I have an angle, I can define this ratio. This is what we call a trigonometric ratio. So the trigonometric ratios come from this main idea. This ratio, A over B, or I'm going to erase this just to show you, or saying opposite leg over adjacent leg. So it's going to be called the tangent of the angle. This, the opposite of the leg over the hypotenuse, is going to be sine of the angle. And this, that we call the adjacent over the hypotenuse, it's going to be cosine of the angle. And these are the main trigonometric ratios. Some people may say, okay, but if I choose A to B, I can choose B to A. If I choose A to C, I can choose C to A or C to B as ratio. And you're correct, of course. So what means this? So it means that in my case, I'm going to name this cotangent of the angle. This is going to be cosecant of the angle. And this is going to be called secant of the angle. Okay, and these are the objects that we call trigonometric ratios. So this is a good point in where you can stop a little bit and think, okay, so what are the trigonometric ratios? Where are the trigonometric ratios come from? I'm just waiting for you to type your comments about these two questions. So now that we have the trigonometric ratios, the good thing is that if you want to calculate any of the values like A or B, you're just going to need one of the numbers, and to calculate the other you need another triangle to have the trigonometric ratio. And the cool part is that you can find in your calculator the trigonometric ratios. So you can, somebody did this job for you. He already calculates all the trigonometric ratios and put it in a calculator. So this is the cool part. So let's go back to our problem of the height. We want to calculate the height A, and we know the distance B, and we know the angle theta. So if you see the trigonometric ratios, you may find out what are the trigonometric ratios we can use, right? So of course I can go with the tangent. So I just need to use tangent of the angle. Tangent of the angle theta equals to A over B, and as I need to find A, I just need to multiply B. So B, tangent of the angle theta, is going to be A. So if I have the angle and I have the distance, I may calculate the height of any building. Cool, right? Why don't you do that? Why don't you go outside and calculate the height of your building? It would be nice that you comment and write in this video what was the height that you estimate for your building, and then go with a protractor, go with a metric tape, or if you don't have metric tape, you can use steps. So measure it in steps, your building. Okay? And this is how you can use trigonometric ratios. Now, just, maybe you want to know, okay, give me a practical idea. So let's say that this B is going to be 10 meters. Okay, we measure 10 meters. And with 10 meters, the angle subtended is going to be at 30 degrees. Okay, so if you go to your calculator, the calculator is going to tell you that the tangent of 30 degrees is root of 3 out of 3, and the distance is going to be 10 meters. So you just need to multiply to know what is the height of your building. Okay? I'm not going to do it. I want that you do it and show me in your comments what is the height of this building. Is it a height you can think that it's reliable, that we can say yes, it's the height of of a building, or maybe I'm just guessing and the numbers are not accurate. I think that maybe you can have a little surprise with the height of this building. And that's it. This is how you learn about trigonometric ratios. In this video, you have learned three things. First, you have learned some applications of trigonometric ratios. Second, you have learned and know what are the trigonometric ratios. And third, you know why or where is a trigonometric ratio coming from. Okay? So these are the three things that you know about trigonometric ratios. And just to end with this topic that is, for me this topic is something that I really enjoy because I'm seeing everywhere in physics and science. We use it all the time. So just for you to end with this, imagine that this is the way we can calculate the velocity of an object that moves in two dimensions. So we just need to know velocity in x, velocity in y, and we can calculate the velocity by Pythagorean theorem, and there's an angle subtended. But more important is that sometimes we have the angle, and let's say that in this case the angle is 20 degrees, and we know one of the components, Bx or Vy, so I'm going to tell you Bx is 2 meters per second, 2.0 meters per second, and we want to know the velocity. Just tell me, how will you solve it? Write in the comments what would be the value of the velocity using our trigonometric ratios. So I hope that you enjoyed this video. I hope that you like it. I hope that you get encouraged in seeing more applications of trigonometric ratios and triangles, and write me. If you enjoyed this video, please like, subscribe to my tube, and remember, see you in the next video. Bye bye.